everyone, so today it's Coach Fred here, and today I'm going to be going over simplifying radicals that are not perfect squares. Now, there are lots of methods for doing this, and every teacher might teach it a little bit differently, but the goal is the same. The goal should be to find the largest, not the largest perfect square that is a factor of the number, and simplify it using that perfect square. So here's an example. The square root of 8. Well, the largest perfect square that is a factor of 8, and here I've listed some common perfect squares in order, would be the number 4. So I can use the property of radicals and multiplication and rewrite this as the square root of 4 times the square root of 2. Properties of radicals basically say that the square root of A times the square root of B equals the square root of AB. So now I'm just working backwards. All right, well, we know that the square root of 4 is 2. So this would then simplify to 2 square root of 2. And that you should know is being multiplied. So it's 2 times the square root of 2. All right, 24. The square root of 24, I can see that the largest perfect square in 24 is the number 4 again, okay? So I can rewrite it using multiplication. So the square root of 4 times the square root of 6. So in simplified form, square root of 4 is the number 2. So this would become 2 radical 6. Okay, again, it's 2 times radical 6. It's like me having two radical 6s. So I could actually write it like this, root 6 plus root 6, because that would give me 2 radical 6. All right, the square root of 48 is a little bit more challenging because kids are going to want to jump to the number 4. And I want you to think about it 2 different ways. Number 1, if 4 goes into it, I think it would be appropriate for you to always check the number 16 if the number's larger. Because a lot of times 16 might be a factor of the number. And here's that case. 4 went into it, so I decided I was going to check to see if 16 was a factor. It was. So I could rewrite this then as the square root of 16 times the square root of 3, giving me in lowest form 4 root 3, okay? Now, I want to go back to that one for a second. The square root of a number can never be less than half the number, okay? It has to be close to half the number. So one other trick that you could use, it's not really a trick, it's the concept. If you cut the number 48 in half, you're at about 24. So if a perfect square is a factor of it, it has to be less than 24. So I would actually work my way down the perfect square list, and then that would have me starting at 16 as well. Now, look what happens, though, if I do use 4. Okay, I've got the square root of 4 times the square root of 12. Well, the square root of 12 has another factor in it, so you'd actually have to do that. And this is what you'd end up having. You'd have the square root of 4 times the square root of 4 times the square root of 3. So that would give me 2 times 2 root 3. The reason this isn't the best way of doing it is because oftentimes kids do that one simplification and then they stop. So they don't recognize that 12 is not in its lowest form. Okay, so let's go back to this. My hint to you is if 4 goes into it, check 16, okay? All right, and we're going to get to this next one. I know you're going to jump at 72 and you're going to want to say, oh gosh, 9 goes into it, 9 times 8. But 9 is not the largest perfect square. It's a perfect square that's a factor. If 9 goes into it, I actually always check 36. So 36 does go into 72. It goes in 2 times. So I can rewrite this as the square root of 36 times the square root of 2, which would give me 6 root 2. All right, so that's the method. Again, my tricks for you really are, if 4 goes into it, why not check 16? If 9 goes into it, why not check 36? Or take half the number and work your way down the perfect square list from there. And that might be something that would help. All right, let's try a few more. How about the square root of, 54. 54. Okay, so I'm thinking of my perfect squares. I actually usually write them down just to remind me. Okay, and I'm looking and I see 9 goes into it. 9 is a factor of 54. I check 36. 36 is not a factor of 54, so 9 is the largest perfect square. So I can rewrite this as the square root of 9 times the square root of 6, which would give me 3 root 6. All right, let's try another one. maybe, here, let me erase that one. Let's try 75. Well, that one's interesting because when it ends in a 5, I always check 25, right? So I can see that 25 goes into 75 3 times. So I can rewrite this using multiplication as square root of 25 times the square root of 3, which would give me 5 root 3. All right, let's try another one. Maybe, how about square root of 108? I love this one. Square root of 108. So I might use my calculator here, and you might see that 9 goes into 108. But if 9 goes into it and it's a large number, you're going to want to check 36. Okay? So I'm going to do that work on the side. I'm going to see, does 36 maybe times 3 give me 108? And it does. So 36 is a factor of 108. I can rewrite it using the property of multiplication as root 36 times root 3, which would give me 6 rad 3. All right, guys, so that's my quick little lesson on simplifying square roots, and we're going to be putting this to work when we use quadratics and we solve quadratics in vertex form. Have a great day.